Hello everyone, I'm Gábor Kisrámosi and we have just released LVGL UI Editor version 0.2. In this video I will show you all the great features and updates that we have added to it. Let's start in LVGL/LVGL_editor GitHub repository. This is a public repository where we have issues, examples, a README with introduction, get started and other useful information. And we also host the releases here. Actually, we have already released version 0.2.1 as well with some fixes. So if you click here, you will find a Linux, a Windows, an ARM Mac, and an AMD Mac build as well. I'm on Linux, so I have already downloaded this one, extracted it to get an app image, made it executable, so now I can start it. In order to show you as many things as possible, I will create a new project and start everything from scratch. I will name my project Hello and create it on my desktop. So this is how a new project looks like with a basic file structure. Note that in this version of the editor, you still need Docker to be installed. It's a dependency of the editor. In the new versions, somehow we will make it embedded to the software itself so that you don't have to take care of it. To check if it's available on your system and up and running, just open a terminal and type docker --version, and if it prints something like this, it should work. So the first thing that you need to do is click this generate code button, and when it's ready, click the compile project button as well. It will recompile LVGL and all your custom C code, which is not that many so far, into the editor. So both LVGL and your C code can be used and will run in the editor's preview here. After that, we can create our first component. We have improved the functionalities of this file navigator. Now if you click on a folder, you can create a new file, a new folder, and use some basic file and folder operations like cut, copy, paste, rename, and delete. So let's create a new file. Let's name it thermostat.xml. And let's see what we can do here. Let's start by typing an opening bracket. This autocomplete, which is also a new feature, shows you what you can do here. You can create a component, a screen, or a widget. As I have created this file in the components folder, I will create a component now. Now we can see what we can do inside a component tag. To get started, we will create a view. As the view tag is created, the preview is rendered because now it knows what to draw. I don't want to start with just an LVGL widget. I want to start with an arc. So I want my root widget extend an LVGL arc. And now we have it. It's a little bit odd that this knob is clipped here, but fortunately there is a solution. I can create a new preview description like this. I can adjust the width of the preview. Let's make it just 200. And the height, it's also 200. And I can also add any kind of LVGL style properties like a padding. Let's make it 20. So now I have some space between the edge of the preview and the view itself. I can also change the background color. Style BG color can be used here. If I click on this color, I can also use this color picker to set a new nice color. Let's add the label to this arc. Align it to the center. And change its text to something. Now the label and the arc has nothing to do with each other. However, as the next step, I like to show you how to connect the label and the arc in a simple way. To do this, I will use an LVGL feature called subjects and observers. The subject can be imagined as a global data having some values like integers, strings, colors, pointers, this kind of things. And the observer is a callback which can be subscribed to a given subject, and if the subject's value changes, all the observers will be called so that any interested parties are notified of the new value. In the editor, what you can do is go to globals.xml. Here we can have some API parameters, constants, styles, images, and fonts, like in the global scope. But now we will add subjects. Let's create an integer subject. Let's name it temp1 for temperature 1 and set the default value to 10. Let's create two more, temp2 and temp3 as well. Let's go back to our thermostat, and instead of setting the text to 1, 2, 3, let's use the bind text property and use temp1. The text of the label immediately changes to the subject's default value, which was 10. I can do the same thing with the arc as well, but here I need to use the bind value property, and I connect it to the same temp1 subject. The arc immediately jumps to the value of the subject as well, and now if I change the arc, the label changes as well. But as one of the key features of this editor is being component-oriented, you can do something very interesting. Let's create a new API for our thermostat component. It will have a single property right now. Let's call it temp, and its type will be subject. And in the end, let's reference this temperature property, which will be passed later, here, instead of setting a subject directly. So nothing is used here, but if I want, I can define a default value, maybe temp1. Let's continue by creating a new screen. I will do it in the screens folder, main screen.xml. Obviously, I will start with the screen tag here, also create a view. I will make it a little larger to cover the whole preview. And I will create some instances of my thermostat. The new property that I have defined is immediately suggested here, so I will use it, and I will use temp1 here. Let's create two more instances. Now these are on top of each other, so I will use a layout. Let's arrange them in a row. And let's apply wrapping. Okay, it seems a little large, so I will go back to my thermostat and make it a little smaller. Okay, something like this. And now they fit in a row. I'd like to show you another data binding thing. I will create a checkbox. Its text will be hide arc3. It doesn't do anything right now, obviously. But if I create a new subject called hide, and its default value is 0, go back here and define bind to the checked state this hide subject. Now the value of the subject changes. To show it, I can quickly create a label, bind the text to hide, so it's there. And to connect the value of this subject to an arc, I create bind flag if equals. So if a value of a subject, let's use the height subject, is a given reference value, which is, let's say, 0, then apply an LVGL flag, which will be hidden in this case. Oops, it works the opposite way, so I need to apply the hidden when the value of the checkbox is 1. And now, if I click it, it's hidden. I don't like it jumping, so I'm just adding this setting, flex in new track, so it will place it in a new track, like this. Now let's discover how events are working. Let's go to the thermostat component, and here as the child of the view, start typing lv event call function. You can set a callback. I will use a name like arc changed. The trigger will be value changed. And if I want, I can also use some user data. I will use foo in this case. Let's see how the generated code looks like. So in the generated C code of the thermostat, I will have a create function, bind value to a parameter, which is defined here when the thermostat is created. So in the C code, you can pass these parameters. Set the width and height, create a label on the arc, align it to the center, bind the same subject to the label's text, and create an event. It uses the callback name that I have specified. The trigger is here, and this is the user data passed as a string. Now if I recompile it, and go back here, I see that arc changed, so my callback was called. It's printed because in this main generated file, this function is created. So my arc changed function, and it logs this default text. It's compiled only if we have this editor preview compiler setting, so it's only for the editor. In your application, you need to define it yourself, obviously. However, it's defined as weak here as well. So if you want to make any kind of experiments, you can use this file, which is not generated, so it won't be overwritten. And just do whatever you want. I will just change this log text. Compile it again so that my custom C code will be part of the editor. And now my callback was called and my C code was executed. Once we are here, let's discover the inspector feature as well. It can be activated by clicking this button. And after that, if you hover on a widget, you will see its bounding box. If you select it, its position can be changed. The size can be changed as well. If the child is selected, it can be adjusted in the same way. The preview and the XML are also connected in this mode. So right now I have the label selected. That's why the label is highlighted here. And if I have the main, the view selected, then I have the arc, the view part selected here as well. It works the other way around as well. If I click the label, it highlights the label. If I click the view, the arc, it highlights the arc. It's a very handy feature to easily find widgets and to better understand complex layouts where you have like nested transparent containers or so. Now I'd like to show you some widgets which are available in this version of the editor. I will use the main screen as a playground. Let's remove this and start with LV table. I set the column count to 2 and the row count to 3. It's a little bothering that I can't see the separation line here. This is the default style of a table in LVGL, but we can easily change it. Just create a new style. Its name should be cell. And let's change the border side to full. So now we will have border on all sides. We just need to assign it to the table. Let's assign the cell style to the items, because the items here mean the cells of the table. All right, let's add some content. The general rule is that if you would like to add some special dynamic content to a complex widget, you need to start with the name of the actual widget and type a dash, and after that you will see what you can do. So now I will add some cells, because I want to change the value of the cells. Let's target the first column. It's 0 base, so it's 0. And the value can be something like this. Let's add it multiple times. As I don't have too many text here, this column could be smaller. To do this, we can select the first column and set its width to something smaller. Oops, it's too small. Let's try 31 or 32. Still not enough. Let's try a smarter way. If you keep pressing Ctrl or Command on Mac and the up and down arrows, you can change the integer values like this. If you also keep pressing Shift, it will jump faster. All right, let's add a value to the second column as well. Now if I add the value to some larger row like 30, the whole screen will be scrollable. But if you change the height of the table to something like 200, now the table is scrollable. It's not an editor feature at all, it's a generic LVGL feature. This is how the table works. But I think it's very nice to see how fast you can try out something, how fast it is to iterate with changes in the editor. Okay, the next widget that I like to show is the chart. It's out of the screen right now, so I will start with setting its height to 100% to make it fit perfectly. And following the same rule that we have seen in case of the table, I will start some special children with the name chart, dash, and series. The color will be red, and add some values like 1, 2, 3, 4, 5. These are a little small to the current range, but fortunately I can change the range as well. I need to select an axis. The axis will be the primary y-axis, because this is the default axis to which the series are mapped, and the range, let's say it will be 0 and 10. The same way, I can also add a new axis. Let's make it blue. Let's just use some larger values. It's completely out of the screen, but I can change its range and map this series to the other axis. And that's it. I can also create a cursor for the chart. Let's make it blue and set the cursor's position to 30. So I have a line here. I can change its style as well. I will create style, name, cursor, and line dash gap, so it will be a dash line, and line dash width, also 10. In the same way as we have seen in case of the table, I need to assign this style to the cursor using the cursor style and assign it to the cursor part of the chart. Using the arrows again, I can change the parameters here easily. Line width can be applied here as well. Like this. The next widget is the Spangroup. At first look, it might look like a simple text or simple label, but it can do a few interesting things. For example, if I create a new style called red and change the text color to red and assign it here, now it's red, but it can do more. But to show it, I need to create a new font. So now we can discover the fonts as well. Go to the global.xml, and here in the font section, we can define our fonts. I created a TTF font here. Just copy it in the fonts folder. Go back to the editor. And here, let's start describing the fonts that we want to use. Let's create a tiny TTF font first because it's simpler to demonstrate in the editor. Tiny TTF is a library to read the TTF files and render the bitmaps directly from it. The name should be big. And for the pass, I just copy it. It can be relative pass. So like this. And set the size as well to something large like 32. All right. Let's see. Nothing happened so far, of course, because we don't use this font yet. But now I can use it, and the autocomplete also offers the only font that I have right now. And now this is larger. If you would like to go for the more standard way of using fonts, you can choose bin here, generate code, save all the files. And now you have this C file generated, which is like a standard font file for LVGL. Once talking about code generation, let's go back to our playground and give a name to this span group. It will be, let's say, title. If I generate code, it will generate something like this. So instead of using some automatically generated name like LV span group 1 or so, it will use the name that I have used, and it will also set this name for the widget. And this name is very useful because by using this, you can easily get any child or any widget on the UI by name at runtime. So if you create this widget with this name, you can easily find it at any time. And that's all about the new features for now. However, you might also be curious of what we will work on in the near future. So we have decided to have more frequent releases. We are targeting every Tuesday each week, so you will have access to the new features and bug fixes earlier. Our VS Code plugin and Eclipse plugin are almost ready as well. I will record a separate video about it. We are working on some Figma integration updates to automatically get style properties and images. This will be out in a month or so as well. If you have tried out this or any newer version of the editor, please go to the LVGL/LVGL_editor GitHub repository and open a new issue if you find any problems. Thank you very much for your attention. I hope you will enjoy using the LVGL editor, and see you on GitHub. Bye bye.